We're ready to roll. So today we're going to talk about transformations of polynomials. And like I said, this is kind of nice because we've talked about transformations a lot in the past. We talked about transformations of quadratics, of lines, of absolute value functions. So all those little rules we talked about, if we want to move things left or right, up or down, reflect them around axes, stretch them and shrink them, all that stuff, same rules apply to this, except we're just going to look at it with polynomials then. Okay? So if I have some sort of equation of a polynomial and then I want to do some sort of transformation to that polynomial, then we can rewrite what that thing's supposed to be. Okay? So I'm just going to ask you guys, because maybe we don't want to mess with spending time doing it. Maybe you guys would feel safer having it up there. So I'll ask you, do you want to review real quick what the rules are?
Sure.
Yeah? Okay. All right.
All vertical transition.
Just let me write it down. Okay, so vertical translation of A units. So A is like a variable here. So that would be f of x now becomes f of x plus A. Okay, you guys remember doing that? So if it's a vertical translation, that means up or down, right? So you just add or subtract onto the end of it, whatever it's going to be. Okay. A horizontal translation and let's say B, since we already used A. That would be f of x is now f of x minus b. And the x minus b just refers to the fact that it's going to be the opposite. So if you want to move it to the right, you're actually going to see a subtraction in there. And if you want to move it to the left, it's actually going to be an addition. You guys remember that? The horizontal stuff is always the opposite of what you would expect. The vertical is always the same as what you would expect. Okay? That's what I'm hoping. Okay, a reflection in the x-axis. Okay, so I'm going to reflect something over the x-axis. How do I change the equation then? Put a negative in front of the whole thing. So f of x becomes negative f of x. Okay, that's an x-axis reflection. If I'm going to do a y-axis reflection, it's pretty similar. It's just making the x negative instead of the entire equation negative. So f of x is going to transform into f of negative x. So you'd go through the entire equation, switch every x to a negative x, and you got it. Okay? So those are your translations, your reflections, and then we've got our horizontal. Well, I guess that's sorry. I'll go vertical first.
Vertical, horizontal, stretch.
So do a vertical stretch or shrink. So when you're doing a vertical stretch or shrink, it's a multiplication, but it's a multiplication on the outside in front of the entire equation. And I guess I'll use C. Okay. And so how do we know if it's a stretch or a shrink? Let's do this. What has to be true about the number C that we're multiplying in front there if it's going to be a stretch? Yeah, Jason. Has to be bigger than 1. So we're going to put underneath here, if C is bigger than 1, stretch. And then the opposite, obviously, then would be the shrink, right? So if C is less than 1, shrink. Okay, so that's doing vertical, multiplying on the outside. Horizontal,
Isn't it just the opposite of vertical?
yep, it is. And also, you're not multiplying on the outside, you're multiplying on the inside again. So this is going to be f of, and I guess we'll use d this time because that's next in the alphabet. You multiply each x by something. Okay? And it's going to be the opposite again. So if d is greater than 1, is it a stretch or shrink then? That makes a shrink this time. And therefore, if d is less than 1, that's the stretch. Okay? So, those are all your rules that we learned about before. Okay? Dealing with lines and absolute value and quadratics and all of that. So, let's see if we can take some polynomial equation and apply some of this stuff to it, like we were doing before. Okay? I think we can do this. Mm-hmm. Oh, you're nice. All right, so we're going to start with some polynomial. Let's say we've got this cubic, 3x to the third minus 5x squared plus x minus 7. So let's do a vertical translation of 3 units up. Where? Oh, that's an A. Sorry if you can't see that. Yeah. So I'm going to ask several different ones for this. So vertical translation of 3 units up followed by a reflection in the y-axis. Okay, so we got 2 things we want to do to this in order. Okay, first we want to move it 3 up, then we want to reflect it in the y-axis. Okay, so first things first, if I'm going to move this thing up 3 units, how am I going to change it then? Jake?
The negative 7 turns into negative 4.
Okay, because we're going to add 3 to the entire thing. Okay, so we take 3x to the third. Now for some of you guys, this might look like overkill what I'm doing right here, but this is just to drive home the point. You take the existing equation and you add 3. Okay? And then some of you said, okay, so that's going to make a minus 4 at the end instead of a minus 7. If you just combined up your like terms there, that's going to make 3x to the third minus 5x squared plus x minus 4. Okay, so that's the first step. Got it. Okay. Now I want a reflection in the y-axis. What do I need to do to my equation now? Somebody who's not spoken yet, tell me to change it. Oh, you've already answered some stuff. You haven't yet. Go for it. And not only that one, but all of them. Okay? So we're going to take what we have right here and make every x a negative x. Okay? Okay. And we got to simplify this thing still a little bit. Okay? Yeah?
Instead of putting the parentheses over the negative x
Yeah.
by itself,
Mm-hmm.
just make it minus x.
Then it would look like the beginning of that equation. If I didn't have the parentheses there, it would look like 3 minus x to the third. And it's not.
I'm talking about negative, all right, after the negative 5,
Right here?
yeah, right there, the one after that.
This one.
Yeah.
Oh, yes, that one you could. Because there's nothing else going on. It's not being multiplied by anything. It's not being raised to a power. That one you could. Yeah. I just did it with all of them just so that everybody can see very clearly that where I've changed things. But you're right. Okay, so let's go through. We got to think about how powers affect negatives here when we go through and do this. So if I have negative x to the third, think about negative x times negative x times negative x. It would be negative by the time you're done, right? Because you've multiplied a negative 3 times. So that negative I can pull out onto this 3 then. So it's negative 3x to the third. Now this negative x, I'm squaring. What's going to happen with that? This is going to turn positive. So this will still stay a negative 5 in front here then. It's not affecting that, right? Because it's a negative times ultimately a positive there. So minus 5x squared.
It'd just be minus
And just minus x because you're adding a negative x, that's minus x. And then negative 4, nothing's going on with that guy. So here's you doing the second step, and then this would be the final thing all simplified together then. Okay, so does that process make sense, what I just did? Okay, same rules as before, right? We just got to be careful that we're doing it with everything in the polynomial as we go. Okay. So let's take this same polynomial. Let's see if we can apply some different types of transformations to it. So how about this time we do a horizontal shrink of a half followed by a horizontal translation 4 units to the right. Okay, and I'm not starting with the answer to the last one. I'm going to start with the first one we had at the top, okay? So we're not just like continuing on. We're going back to where we started and doing this kind of from the beginning. Okay, so if I'm going to do a horizontal shrink of 1/2, what am I going to do to that equation then? How is it going to be changed? Yeah.
Aren't you going to have to use the reciprocal of 1/2?
I am. And what am I going to do with the reciprocal of 1/2? All right, anybody want to help him out? He's got us halfway there. Yeah. Multiply each x by that reciprocal. Okay? Just the x's. Yeah, because take a look. If I'm doing a horizontal stretch or shrink, it's f of d times x. So this d for us this time is 2, right? So I'm going to multiply that by the x.
So vertical stretch, that would be multiply everything by half.
If it's a vertical stretch, yes, you multiply everything. Horizontal stretch, you just multiply each individual x in the equation.
Sorry, on the vertical
It's okay.
stretch,
Yeah.
would you even multiply like the ones that don't have an x on them?
Yep. It would be like what we did right here. So if I had a vertical stretch, I'd put parentheses around the entire equation and then multiply it by something in the front. And then I'd have to distribute that all the way through, right? But this one's a horizontal, so I'm just going into each individual x and doing that, okay? So take a look at this original equation we got up here, okay? So I'm going to take that guy, and everywhere I see an x, I'm just going to turn it into 2x. But make sure you're doing that whole little parenthesis on each one thing again, okay? So we're going to have 3 times 2x to the third minus 5 times 2x squared plus 2x minus 7. Okay, there's my horizontal shrink of 1/2. Now I can simplify this thing up, right? Yeah. Each one of those 2x's raised to a power or whatever, those are going to change as I multiply, and then I can rewrite it this thing and go from there. But that's how you set it up, at least to get it started. Zach, did you have a question? Okay. So 2x to the third. That'd be 2x times 2x times 2x. What does that get you? 8x to the third. Okay, so I'm going to just write that out. 8x to the third like that. Minus 5. Now what's 2x squared? 4x squared. And then 2x as well, just 2x. And the minus 7. Okay, and then I got a little multiplying to do here yet, right? 3 times 8 and 5 times 4. 3 times 8 is 24x to the third minus 20x squared plus 2x minus 7. Okay, so this right here is setting up the horizontal shrink, and then all of this is where I'm at when I'm done with the horizontal shrink. Okay, now I want to move everything 4 units to the right. How do I do that?
Did you add 4 to the negative 7?
Nope. That would be if I'm going to move it up 4. Add 4 to each x. Actually, not add 4. Subtract 4. Remember, it's the opposite, okay? Horizontal stuff, it's always the opposite. So each x is going to become x minus 4 to do that.
Because in the parentheses, it's in different order.
Now this stuff I will not make you try to simplify because goodness gracious, it would get crazy. Just recognizing, so here's our second step right here. So just recognizing that each one of the x's needs to be an x minus 4. Okay, good enough. Because otherwise, if I wanted you to like completely simplify this thing, imagine what that would entail. You'd have to take that x minus 4 to the third, so x minus 4 times x minus 4 times x minus 4, do all that FOILing out and multiplying, and then you'd have this x minus 4 times x minus 4 in the middle, and multiply that all together. It just gets crazy. So we'll leave, no, it's not. We're not doing that. So leave it like this. My pre-calc class doing this? Yeah, maybe. But Algebra 2, I won't make you guys do it. That's good for them.
If they got that.
No, probably not. I'm just joking. But if I was really, feeling mean, maybe I would.
They probably know how to do that other stuff.
It's true. But sometimes we need to analyze it all put together. And anyway, question.
So wait, why is it?
Because we're doing a translation 4 units to the right as our second thing here. And so a horizontal translation, it switches the sign from what you would expect. So these all have to be minus 4s on the x's, not plus. Okay, so got the basic gist of applying it to a polynomial?
Wait,
Now we're, yep.
what happened? Okay. Okay, I get where you got the 24 x minus 4.
Mm-hmm.
But then what happened to the other x minus 4? Because it was negative 5 and 4. Where's that?
We're starting from here now. This is after we did that stretch, or that shrink rather.
Oh, I was looking at what
You're going back up to the top? Yeah, okay. Yeah, so we've already done the first thing. It says followed by, so we need to take our result from the first thing and then apply the rule to that thing. Okay, so now that we've done it this direction, remember before we also analyzed it the other way. So if I give you an equation of something that's already been transformed, can you work back and tell me what happened to get it there? Okay? Yes, you can, and you will. Let's try that. So the directions on these kind of problems would say something like describe the transformation. All right, so describe the transformation of f of x equals x cubed. So this is my parent function, or this is where I'm starting from, okay? So f of x equals x to the third. And so I did some sort of transformation, and now I have this new function. I'm going to call it g of x, because it's different now. And let's say g of x is negative x plus 2 to the third minus 3. So can you tell me what happened? And can we put it in order, too? So what happened when to this thing? Okay, so, Jake, what do you got?
First, you should have done a vertical translation of a negative 3, and then a horizontal translation of negative 2.
Mm-hmm.
I'm so smart.
And you're also you're missing one thing, though.
I'm not.
Take a look. Take a little closer look at it.
I see the negative
Over the x. Yeah, it's over the x. So, okay, shh. So we've got a down 3 happening, we've got a left 2 happening, and we also have a reflection over the x-axis. Okay? By looking at the equation of where these new pieces are put in, shh. Notice how the minus 3 is on the outside. It's just tacked on the end. Okay? That's a vertical translation, up or down. This plus 2 in the middle, that's a horizontal movement if it's in the middle, like that. And because it's a plus 2, and we know horizontal is always the opposite, actually that moved to the left 2, not to the right. And the negative in front of the whole equation is a reflection over the x-axis. So it's just knowing those rules and being able then to see them in there, which it does. It does. So we need to be careful here. So here's what I recommend. We did this before. If we start with x to the third, So this is our starting point. And then let's just build this up one thing at a time and then describe what's going on, okay? Because a certain order will work and a certain order won't work because, well, I'll explain when we're done. But, so the way that Jake described it was the first thing he wanted to do was to move it down 3, correct?
Yeah.
Okay.
Is that wrong?
I'm not saying that yet.
Yeah, that's wrong. Wait, kept me interested. I might have learned something there. Dang it.
All right, so watch and see if you learn something. So he said down 3, so that would produce x to the third minus 3. Okay? So then if we take that thing that we've created now and move it to the left 2 would give us this. And then he said reflect that over the x. Okay. If I reflect that thing over the x, that means I need to take that equation that I'm looking at right now and multiply it by a negative 1. Am I going to get the right equation when I'm done? Yeah, it would had to have been a plus 3 to start with to make it work, right? Leaving that a minus 3 right now, if I were to do that, it would look like this. So that would be our reflection over the x. So if I did it in that order, I'd get this, which is wrong. So something happened in there where I went the wrong way. Or could I go back and fix something in one of those earlier steps so it does work out right?
Yes, you could.
What could I do to make it work out right? I could start with the reflection. That would do it. What's another thing that you guys see that I could maybe do that would help? Do what? Go up 3 first instead of down 3. Do you guys see that? If I had made that thing an up 3, and that would have produced a plus 3 to start with, and then at the end when I went through and multiplied everything by negative 1, that plus would flip back to a minus. So that would work. Now, I think for you guys, it probably makes more sense to just do the reflection first and then go from there. Because then everything looks in the equation the way it's supposed to be. But this is why we do this thing, though. This is why we have to show each individual stage along the way, because you might end up making a mistake like this one, okay? It's not calling you stupid, but anyway. So let's start again. Let's start again, and let's do it in a different order, okay? So if we go reflection first, so I got negative x to the third. So reflection over the x on that. And then after I do the reflection, I do my left 2 and my down 3. Then it'll work. Now think about why this one works and the last one didn't. Because at this stage right here, okay, I need to take what I'm looking at, this particular equation, and move it down 3, so you tack a minus 3 onto that. Negative included, the whole thing. Okay, so that makes a little bit more sense. It fits together the way it's supposed to. So if you do the reflection, then left 2, then down 3, it'll work. Actually, I don't know if you guys noticed this, but these last 2 don't really matter, right? They could go either way. You could go down 3 first, then left 2. You would end up in the same place. Okay, so that's the trick. Sometimes you end up in the same place if you switch an order on something. Sometimes you don't, but you just have to write it out and see what happens. Okay? If you do it as a little chart, that'd be beautiful. Yeah. Okay? If you can think about it in your head and get it to work out and you know the correct order, just write the order of what you need to do. My recommendation would be to do this, though, because it's hard to do this in your head sometimes. Okay, so let's try another one of these, okay? See if you can do this again. Okay, so this time we're going to do a parent function that is x to the 4th. Okay. And let's say our new function g of x is four times x plus 3 to the fourth minus 8. Okay, try that one on your own. If you need to make the little chart or whatever, go for it, but see if you can describe what happened to this thing and in what order did it happen. All right, so who thinks they can give us a good first
I know for a fact.
step? Okay, go for it. What do you think?
Vertical stretch of 4.
You want to start with a vertical stretch of 4. Okay.
That better be right, and if I'm not, I will walk out of this classroom.
Okay.
That's really reassuring.
All right, so vertical stretch of 4 to start off with. Okay. Anybody else? Somebody who's not spoken on this one yet? Yep. And then go left 3. Okay. All right, and then what's left over to do? I got to get that minus 8 somehow. So what is that transformation? Somebody else? Yes. And down 8. Yeah. All right, that order will work for sure. Oh, 8, right, not 4. Yeah, that order is fine. Okay, you do the vertical stretch first, then you move it left, then you move it down, and then that equation comes together the way it's supposed to work. As long as you didn't do the vertical stretch last, that's going to be a problem. Okay, if you do the vertical stretch last, you would already have the minus 8 in there, and then you'd have to multiply the entire equation by 4. See what's going to happen? See why that's a problem? Unless you start with a minus 2, yes, that would work. So if you move it down 2 to begin with and then multiply it by 4, you're good. But if you try to do the down 8 and then stretch it by 4, not going to work. It's not going to work. So stretch comes first, you're good. Then you can do it just like you see it. So, okay. That's in general, that usually works best. Yeah, if you do your stretches or your reflections first and then your translations after that, it works out better. Yep. Okay, last thing I want to show you guys, and then we can get to some homework here. Just a little notation stuff for you. So let's say we've got f of x equals x to the third plus x squared plus 1. If you see something like that, that's actually describing a type of transformation, but it's doing it with this function notation stuff. Okay? So if I want this new function g of x to be equal to, put the table down, f of negative x, what am I really doing to this function of f of x? Yeah. Right. If you look at those rules that we wrote down at the very beginning here, didn't we say f of negative x meant that we were doing a reflection in the y-axis, right? So g of x is now representing a reflection in the y-axis. So just think of it that way. And you can just follow what it says there. So take f of x and change every x into a negative x and do that same kind of process that we did earlier. It's just written a different way. Yeah?
For x squared, would that just stay the same?
It would, right. So my...
Negative x to the third or plus x squared plus 1?
Yeah.
This is so simple.
So my recommendation, just to be safe, would still be to write it out like that and then think about what each power is going to do and that sort of thing. So in this case, g of x would equal negative x to the third plus x squared plus 1. Okay? So that would be applying that particular rule. And they might ask you then, too, what is the transformation taking place? It's a reflection on the y-axis. Okay, well, what if g of x was like f of x plus 2? Well, what am I doing this time? What's the transformation? Horizontal what? Translation to the left 2. Right. And so you could do the same idea, just kind of following the formula here. So I'm going to take f of x, and every x is now going to be an x plus 2. And again, with these, don't feel like you actually need to multiply these all out. That's fine. Be something like that. Okay? So the notation could be used like this to rewrite the equation, or it could be used to do something with the graph, where they just give you a graph of the polynomial. So instead of an equation, let's say we have, I know, I can hear it. So let's say that this is f of x, and I'm told to do a transformation g of x equals, how about negative f of x? Okay, so we need to think about what is the transformation that this little thing right here is telling us to do, and then this time, instead of making a new equation, we're going to make a new graph. So think about, on the graph, how would I change things up to make that thing to work the way it's supposed to do? So somebody who has not spoken yet today, not you, what's actually happening to this graph if g of x is equal to negative f of x? It's an x-axis reflection, okay? So I'm going to take what I have and do an x-axis reflection of that, okay? Okay, so to make this thing look like it's reflected over the x-axis, what I would start with is take each point where it hits the x-axis, because those are still going to stay the same, right? Uh-huh. And then it's just going to go the opposite way. So instead of coming up, it's going to come down, and then it's going to come down and touch and go back. So it's going to look something like that. So this then would be a graph of g of x. You can't do that, because then the bump would be over here.
Yeah, Robert.
But nice thought, though. Anyway, so with the graph ones, too, it's not supposed to be crazy hard. It's just you need to recognize what the transformation is, and then just try to make the graph look like that. Okay, it's just a sketch. It's nothing totally majorly detailed. Okay, 9. All right, so that's all I got for your notes. For at least, guys, stop. For at least one question on your homework, you need to read the section. Okay? Just like the last one, you had that one about the complex conjugates theorem that you need to go back and take a look at. There's at least one here where you're going to have to go back and read. Okay? So maybe just start by reading the section. Wouldn't be a bad idea.